Okay, so now let's start diving into the Newton's laws of motion. Okay, so the first set of videos will just kind of focus on what are the laws, and then we'll get into some problem-solving strategies as we go on. So the first, Newton's first law. All right, so prior to Galileo, in around 1600, which is when Galileo was, right? Scientists and philosophers, mainly Aristotle, is the main philosopher here that we're going to refer to, thought that there was a natural state of an object was to be at rest. Okay, so two of the things that Aristotle kind of proposed was this idea of there was an object's natural motion. Okay, then there was an object's violent motion. Okay, and so what Aristotle was saying and proposing was that it was natural for objects to remain at rest. Okay, and then his violent motion concept or idea was the idea that you had to impart a violent motion to get an object to move and continue to move. All right. So the way he thought about it was that a moving object was not in natural state. Right. So this second bullet point here, kind of goes to this concept of violent motion. Now, you have to think. Excuse me. Aristotle not doing experiments, thinking about this stuff in academies. Okay. And then Galileo is now going to conduct control experiments. And then what he actually concluded that an object's natural state was not at rest, but is in motion or moving, all right, with constant velocity. And so according to Galileo, rest was actually a special type of uniform motion where the velocity was zero. Okay. So that's what Galileo was saying, is that it was natural for objects to be moving, where rest was a special type of motion that we know as, or where the velocity is equal to zero. Now, Galileo and Aristotle didn't necessarily write some of this stuff down or kind of generalize it, but that was left up to Isaac Newton. Okay. So Isaac Newton, he generalized the results into what we now know as Newton's first law of motion. Okay, he wrote these laws down in his monumental book called Principia. It's a lot longer title, talking about the natural mathematical sciences of principles or something like that, but we just call it Principia. Now, his first law of motion, and I'm going to paraphrase this a little bit, states that an object will remain in a state of motion, right? So it will remain in its state of motion unless acted upon. Sorry, this is kind of long, I know. Unless acted upon by an external unbalanced force. So remember, we talked about how forces will change the motion of an object. So what he is saying, that objects are going to continue to be at rest, or they're going to continue to move in a constant velocity unless you do something to it. And what do you do to it? You exert, right, this external unbalanced force. Okay, remember a couple of videos we talked about how, if an object is a system, for it to change its motion, something has to come from the outside. Okay. Now, Newton's first law does have two kind of sub-names or subtitles. Okay. The first one being inertia. So the first law is often referred to as the law of inertia, where inertia is defined as, okay, the tendency of an object to continue in its original state of motion. Okay. So how do we kind of compare this, right? So there is a physical quantity attached to inertia, and that's an object's mass. Okay, so when you're younger, you learn how masses are objects that contain matter, right? But here we're going to redefine mass a little bit. We're going to talk about how it's just a tendency, it's the physical quantity associated with an object's tendency to change its state of motion, okay? So here's how that works. The more mass, right, the more inertia it has. All right, so a way to kind of equate this, let's just say you're at home, you don't want to do anything. Well, you're going to have high inertia, right? Your parents tell you, or your parents or guardian tell you to, pick up the trash, and you're going to possess high inertia because you don't want to change what you're doing. But then they say, okay, if you pick up the trash, we'll go get ice cream, right? I mean, I would jump for ice cream, but then your inertia goes down because then it's something that you want to do, okay? In fact, mass is sometimes referred to, when we just talk about mass, sometimes referred to as inertial mass. And the SI unit for inertia is kilograms, or the SI unit for mass is kilograms. Okay, so remember, here in physics, we use the MKS metric system, so meters, kilograms, seconds. So all of our masses need to be into kilograms. Okay, and then I found this out the other day, but the interesting thing is the US equivalent to kilograms is actually called slugs. And one slug is approximately 32 pounds. Like 32.1 something pounds, okay? I just found that interesting, okay? Now, Newton's law of motion, his first law of motion, is also sometimes called the law of equilibrium. And this part of the law kind of brings about one of the classic misconceptions in physics, okay? Now, the reason why we call it the law of equilibrium is because all the forces acting on it are in balance, okay, or they're balanced. Okay, remember, we're not accelerating the object, it's traveling at constant velocity, or it's at rest, okay? Now, this is where the misconception comes into play. Sometimes students or people will get confused that it says that objects cannot be in equilibrium when they are moving. They can, okay? I'm going to highlight that because this misconception is something that has to be overcome to understand there is a difference between the types of equilibrium, okay? So the first one is what we call static equilibrium, okay? And static equilibrium means that the object is not moving, right? So it's physically not moving, it's at rest. Remember we talked about the law talks about two states of motion, an object at rest or an object moving at a constant velocity, okay? And so this is dealing with when an object is at rest, it will remain at rest, okay? And you can think of bridges, buildings, or freestanding structures. You don't want those objects to accelerate because they will fall. Okay, acceleration with those type structures is not good because they ultimately would end up falling. Okay, the second type of equilibrium is something that we call dynamic equilibrium. All right, and this is the one that kind of destroys this misconception. Okay, so dynamic equilibrium means that the object is now moving, but with a constant velocity. Okay, so what that means is all the forces that are acting on it. So let's say I'm pulling an object, right? If I'm pulling at a constant velocity, my applied force is balancing out any effect that friction has on it, okay? Or any effect that the tension in the rope has on it, okay? But as long as it's moving at a constant velocity, I am in equilibrium, okay? I am in what is called dynamic equilibrium. Dynamic, another way to think about it, is motion. Okay? In fact, this part of physics at times we'll call dynamics because we're going to study the way or the effect of forces on motion. Okay? And then in the next video, I'm going to jump ahead to the third law, only because the second law is the mathematical law, and that's when we're going to get into a lot of the problem solving. So we're going to jump into the third law here in the next video.